Hello everyone, today in this video we will show you the snubber design for power electronic switch using PSIM simulating software. Now in the introduction of power electronic switch, the semiconductor material are used. So here I have shown the four different power electronic switch: thyristor, triac, IGBT and isolated triac. This is the general block diagram of when the switch is connected with the supply and the applications. So panel it is shown, it is connected with the switch, and secondary side the four different applications are connected. Making the turn on or off any applications, the switches are used. For the simplification I have shown the IGBT, so you also connect the thyristor, GTO or SCR. Now during the switching of any applications, four different phenomena which is created by the switch, it is showing in here. Now this is the V leakage, or you can say this is the transient of the voltage or ringing frequency of the voltage. And second, it is a overshoot. When the inductive or motor load is connected with the switch, the voltage value will be going to upward. So it may also damage the applications or the switch. And this is the voltage spikes or transient of the voltage, and this is the example of the surge voltage. So ultimately these four phenomena can damage the application as well as the switch. Now this is the example. I have taken the photograph of the failure of the switches from the Google reference. Now this is the reference photograph. You can see this damage due to the spike voltage or surge voltage during the switching of many applications. Now this is the introduction of the RC snubber, and this is the circuit diagram. You can see the supply voltage is connected with the inductive load through the switch, or as a switch I have shown the relay contact, and RC network it is connected parallel with the switch. Now how to design the value of R and C, it is showing in this presentation. Now this is the various connection of the RC networks, and first block showing the C, RC and RCD, resistor, capacitor and diode. And also I have shown the equations to find out the value of capacitor and resistance. And I have also provided the detailed literature regarding this equation in video description file, so you can download it from the video description. Below block it is showing the protection against the triac using the RC snubber and RCD snubber. Now before starting the design, I will show you with and without effect of the snubber. So this is without the snubber. You can see the ringing frequency and overshoot voltage it is showing in the waveform. Now using the snubber you can remove the ringing frequency, you can see here, and the below part you can see the overshooted voltage, it is going very much maximum value. So using the snubber you can also control the overshoot or peak of the voltage which is coming from the switching of the operation. Now next is design of thyristor snubber. So there are basically 6 steps are required. So first one is selecting the thyristor applications, and you may find out the voltage and current rating from the data sheet. So for example I have taken the NTE5351 SCR, and the data sheet available in Google also. Now if you want the data sheet you can find out the video description, and that link will provide you the data sheet. Now second is find out the di by dt. It is also given in data sheet only. So if it is not given, then you can take the ITSM which is available in the data sheet. Third one is calculation of the inductor. When you connect the motor load or any inductor for filtering purpose, you may find out the L value using this equation. Fourth one and fifth one, it is used to calculate the snubber resistance and capacitor value. The equation is given here. Now according this equation you can find out the all parameter in the data sheet, and you can calculate the value of C and R. Now last stage is voltage calculation. Now this is the need of the voltage. When you find out the RS value, you have to find out the voltage value which is required to sustain the current amount which is flowing from the resistance. Now detailed equation and how it is coming, or the solution of the equation, it is showing in video description file, you can download. Now for example, datasheet I have downloaded NTE5351, so rated up to the 600 voltage 5 ampere SCR, and red mark it is showing the available value which is required to design the RC values 600 voltage di by dt, ITSM and dV by dt, and using this value you can design any of the SCR protection RC snubber. And also you may download the different SCR or any power electronic switch using the Google or any datasheet provider. Now to avoid the paperwork, I have made one Excel file to calculate the RC value. It will help you to design the RC values directly without paperwork. Okay, now for calculating this number, I made the one Excel file to avoid the paperwork and easily you can get the values. Now from the datasheet you can take these all values which is you have to enter the left hand side green box, and automatically the values will be showing in the right hand side. Now what you have to do is you have to connect or RC number as per your application and you can take the values. Now from the data sheet I have taken the voltage rating 600 voltage and rated ampere it is a 5 ampere, and rate of change on state is 200 ampere per microsecond, and this is also 200. Now I have the application of 230 voltage supply voltage and load resistance 24, and last one is dV by dt. So you can find out the values from the data sheet. You can download. This is bottom side, it is shown dV by dt. Now I will take the dV by dt as 250 and peak load current 8 ampere. So as per giving the all data you can find out the values. You can see in right hand side the 600 voltage, because our rated thyristor it is a 600 voltage, so you can take the 600 voltage, and the capacitor values is zero point 0.1 microfarad and 16.94 ohm, so you can take the random 17 ohm also, and the voltage of the resistance it is a 10 watt. So by this way you can calculate the RC values from this Excel file. So you can download this Excel file. I have provided link in the description, or you can mail to us. Now this is the Excel file for the MOSFET calculating RC number, frequency of ringing and test frequency, damping factor, supply voltage and switching frequency. This parameter you have to enter in this Excel file. So the result will shown in right hand side orange color. You can see the RS, CS and the power it is required for this number, and this is the graph for zeta. You can see the perfect curve, it is a zeta is equal to 1, because this graph or curve zeta is equal to 1 don't have overshoot or undershoot, so it is a perfect curvature for our application. So I have taken the zeta is equal to 1. Now these values, let's say I have calculated this one, so let us start the verification of the snubber design for the switching of any application value which have calculated in Excel file. So this is the PSIM simulating software. So you can take the various component of power electronic switch from the bottom side, and this is the basic window of the simulating software. You can find out the lots of element in this simulating software. It is very helpful. So now for verifying the design of RC snubber, I will take the ready-made example. So let's go to the file and open example. So this software have given the very good example of DC to DC converter. So randomly we will take one of the example, let's say flyback. So this is the flyback converter. All we know the operation of file flyback converter to reduce the voltage. Isolated transformer is required. Now in this flyback converter, input voltage is given 100 voltage and switching frequency 100 kilohertz, and the MOSFET is connected. So now to find out the switching phenomena of the MOSFET, I should connect the voltmeter across the MOSFET. So this is the symbol of voltmeter, and you can rotate also. So now try to connect the voltmeter across the MOSFET so you can see the exact phenomena when the switching. So now this is showing the VP4. So I will write here voltage without snubber. Okay. Now I can also display this name outside. Now running this simulation here, or you can press F8 to run this simulation. Now add this signal which is coming from the circuit. So you can see here easily this is the voltage across the MOSFET, and you can see the spikes is available here during the switching. It is a very upside. You can see it is near to the 350 voltage, and the 200 voltage it is a rated voltage. So this much amount of spike can very easily damage the application as well as the switches which is connected to the circuit. So these things should not be happen in our circuit. So now how to reduce this spike? We have to provide the RC network for this MOSFET. So I will copy this circuit and try to paste here because I need to compare both the circuit with and without snubber. So now I have one circuit here. I will give the name this flyback converter without snubber, and once again I will copy this and I will paste the circuit name with snubber. Okay. Now for that RC network I will need a resistance and capacitor. So you can find out the resistor capacitor from bottom of the component. So this is the symbol of resistor, and same way you can take the capacitor. Okay, I need only two components. So try to rotate from here. Now this is the R and C network which we have to connect the parallel with the MOSFET. So you can compare the voltage across MOSFET. Now it is connected across the MOSFET. Now next is we have to provide the values for the R and C. So randomly it is given 10 ohm and 1 microfarad. So once again we have to refer one Excel file, this file, to calculate the data of the input voltage and the turn ratio of the transformer which is connected with the MOSFET. So you can get the values of this snubber. So I have already calculated these values. So I found the values of resistor. It is 250 ohm, and this is capacitor 3 nanofarad. So I have provided the value for this one. Now try to simulate. Now you can find the values here. Sorry, I didn't change the name of voltmeter. So you can change the name here. The voltage across MOSFET with snubber. You can see the difference. Now again running the simulation and taking the signal, and you can change the thickness of line from here. So your graph will be more visible and you can compare the both graph. You can change the font also. I have take the 16 of size. Now you can see here, and you can compare values. So blue line it is the voltage without snubber, and red line it is voltage with snubber. So you can see the very much closer to the input rated voltage. Red line it is showing the perfect value across the MOSFET, and you can see the overshoot voltage it is reduces by the 90 of percentage. So it is a very much good effect of the RC snubber on the circuit, we can see in the graph. Now this is our objective, to reduce the spikes effect during the switching of any application. So this is the perfect value of the snubber. Now for example, suppose I don't have the value of the snubber. So what will happen, we will see that. So I will take the resistance value 150 ohm and the capacitor value near around 0.1 nanofarad. So we will see the effect of snubber. So we take the with and without snubber signal. You can see here the red line show the ringing frequency because our capacitor is not purely tuned. So the spikes is also near to the blue line. You can see the blue line it is without snubber. So this ringing frequency may also cause the damage of the applications. So this way you can say it is very much important to design the RC snubber. So once again I will set my original value so that I can compare my graph. Now I have run the simulation without snubber and with snubber. Now okay, you can see this is the effect of the snubber. Red line it is without snubber and blue line is with snubber. So this is the importance of snubber. Thank you guys very much.